Hey everyone, welcome to 3.4, Writing Quadratic Functions. In this video I'm going to write quadratic functions. You're going to write a quadratic function when you're given a vertex or x-intercepts and a point on the graph. So you're given like basically at least 2 points, sometimes 3. And so what we're going to do is, depending on what type of point we're given, if I'm given the vertex and a point, I just plug it into vertex form. If I'm given the x-intercepts and a point, I'll plug it into intercept form. Okay, so the first couple examples, given vertex and a point. So remember, your vertex is h comma k, okay, and your point is x comma y. So you're going to be plugging in for everything. So this is what I mean. Here's your vertex form in case you forgot. Alright. So, in this first step in black, I just plugged in my h and my k. And in the second step, I plugged in the x and the y as well. Basically what you're going to do is, you're going to plug in everything you know and figure out what the a should be. Once you figure out what the a should be, you plug it in for the a right here in the black, and then you have your general equation of it, okay? Because once you get the general equation, you want to leave the x and the y in there because, you know, just about every equation you write has y equals and x equals, or f of x equals and x, and an x variable in there. So, you know, f of x is interchangeable with y. So, anyway, I am looking at 21 equals a times 4 minus 1 squared minus 6. So, let's simplify. I have 21 equals a times 4 minus 1 squared is 3. 3 squared is 9. So I'll put a times 9 minus 6. So let me rewrite that so it looks a little neater. A times 9 is 9a. 9a minus 6 can't combine because 6 doesn't have an a with it. So what should I do? I should plus 6 to the other side. Alright? That's going to get me 27 equals 9a. And then you can just divide both sides by 9, and you'll see that a equals 3. Okay, so plug in a right there, and then write your final answer. Y equals, or you could change it back to f of x, but if it helps you, leave it as y equals. But I'm going to write f of x. F of x equals 3 times x minus 1 squared minus 6. And that is all we need to do. So, once you've gotten your final answer, everything can be checked by plugging in your answer and finding the given points in the table. And that's Control-T if you don't remember. So here I'm using the Desmos app instead of the TI Inspire because that's what it's on my calculator, my iPad I should say. But you see a little table on the left, and you see a graph on the right, and so I have both points showing that I was given on the graph and in the table. I see 4 comma 21, and I see 1 comma negative 6, and I typed in the function that I got, 3 times x minus 1 squared minus 6. So that's all there is to it. That's just how you check your work. Let's do the next example. Okay, so my vertex is 6, 3, my point is 1, 7. So label them HK, X, and Y respectively. And so this is where I'm at in my function. I'm missing the A. Basically everything we're doing here is plugging it in and figuring out the A. And then here I've plugged in everything with the X and the Y plugged in. And then I'll figure out the A from this step right here. So 1 minus 6 is negative 5. And negative 5 squared is 25. So you have 25a from this plus 3 equals 7. Again, 25a doesn't combine with the 3 because the 3 does not have an a with it. So you should minus 3 to the other side. Alright, and it looks like we're going to get a fraction answer here because you have 4 equals 25a. And so we're going to divide both sides by 25. And let's see here, does 4 over 25 simplify? I don't think it does, so it's going to be A equals 4 over 25. If you really want to, you can write it as a decimal, but I strongly prefer the fraction. Okay, so I'm going to go back and I'm going to write my function answer, f of x equals 4 over 25 times x minus 6 squared plus 3. What do you think I'm going to do now? I'm going to type this into my graphic calculator to make sure I did it right. Okay, so here I typed in the function. You can't see the plus 3 right here. It went off screen, but trust me, it's there. You see I have the 0.17 highlighted and 6.3 highlighted to show up in the table and on the graph. So, yay, we did it right. Okay, numbers 1 and 2, I guess 3 and 4 really, but determine the equation of the line when given the x-intercepts and a point. So, intercept form. Remember, if you're given the x-intercepts, you're given P and Q. Alright, and so it'll stay minus if you're given a positive number, and it'll change to a plus if you're given a negative number, and I'll show you what I mean. So, negative 4 and 3 were my x-intercepts given to me, so I labeled them P and Q, respectively, and then my point was 0, 6. So, when I plugged in P and Q, it went to x minus negative 4, in other words, x plus 4, and then x minus 3. Okay, that's what I was just talking about. And then I plugged in the x and the y for the full setup. Okay, so if you want, you could skip to the step I did in the red, but I'm just trying to, show you this is where we're at in writing the function. I'm going to get the a and then plug it back in. It should look exactly the same as this, my final answer, just with the number here for a. That's all I'm trying to illustrate here. And yes, this is an a, that's a q. I realize they look kind of similar, but yeah, I'll do the best I can to write neatly. Anyway, let's simplify all this. What's 0 plus 4? 4. What's 0 minus 3? Negative 3. What's 4 times negative 3? Negative 12. So you have 6 equals negative 12a. So all I need to do is just divide. So dividing both sides by negative 12 is going to give me 6 over negative 12, which cuts down to negative 1/2. So a equals negative 1 over 2. And so your function is f of x equals negative 1 over 2, parentheses, x plus 4, close it, new one, x minus 3. Okay, so you see how they look exactly the same, except we've changed that front number. So this is my final answer. I'm going to type this into my graphing calculator, and hopefully it'll match what I just wrote down. So here I have it typed into my graphic calculator, and I see that all the points are there. My x-intercepts are negative 4, 0, and 3, 0, and then that other point, 0, 6, is there as well. Okay, so if one of them is missing, you did it wrong. Alright, that or you overlooked it or something, but yeah, you need to see every point that's given to you in your answer. So, this last one here, you're given 4, 0, negative 6, 0, and 2, 32. So label them. I got P and Q as 4 and negative 6, and X and Y as 2 and 32. So I plugged everything in, and my function is, X minus 4, because it was a regular plus 4, and the formula has minus P. And then it became plus 6 because, minusing Q would minus a negative, which turns into a positive. Alright, and then I plugged in my X and my Y, and here I am. So, let's simplify. I have 32 equals, let's see here, what's 2 minus 4? That's negative 2. What's 2 plus 6? That's 8. So what's 8 times negative 2? Negative 16. So you have negative 16a equals 32. So guess what? We're going to divide. So the math is actually a little bit quicker on this intercept form than it was on the vertex. And it wasn't even that long on the vertex. There wasn't even a whole lot of math to do, I should say. So a is going to equal negative 2. Now that I've gotten the a, I can plug it in and write my final function. F of x is going to equal negative 2 times x minus 4 times x plus 6. You're not writing any power of 2 anywhere because you have two x's. So when you FOIL it back out, or multiply it back out, you'll get the x squared. Okay, so type this in, check the graph. If it matches, good. If it doesn't, we'll figure out what we did wrong. Okay, here's my function typed in. You see two 32's there, and my x-intercepts of negative 6, 0, and 4, 0 are there. So, we did everything right. Let's move on. These last two, I would like for you to try. Alright, so pause the video, and when you unpause, the answers will be here so you can check your work. Okay, so this first one was in vertex form. I knew that because I was given the vertex and a point that was not the vertex. So I labeled them h, k, x, and y. I plugged things in. I plugged in the h and k. So minus and negative 2 become plus 2. Plus 6 on the outside. Need to figure out the a, of course. So I plugged in negative 1 and 3 for my second step. And so negative 1 plus 2 squared is 1. 1 squared is 1 still. So I had 1a plus 6 equals 3. Again, if it's 1a, you don't need to write the 1. So minus 6 to the other side. 3 minus 6 is negative 3, so a is negative 3. So I put that together for my final function as f of x equals negative 3 times x plus 2 squared plus 6. So I plugged it into my graphic calculator, and I should see those 2 points that were given to me. I saw the vertex of negative 2, 6, and the point that was not the vertex, negative 1, 3. Okay, and that's that. This next one, I knew it was in intercept form. Why? Because it gave me two x-intercepts, and then a point somewhere on the graph that wasn't an x-intercept. Okay, so I labeled my x-intercepts P and Q, and then I labeled that point X and Y. So that got me to negative 2 equals A times 1 plus 1 times 1 minus 2. So 1 plus 1 is 2. 1 minus 2 is negative 1. So that's going to multiply to get negative 2. Divide negative 2 to both sides, and you get A equals, I had originally written down negative 1 by accident, so A equals 1. Okay, so if A equals 1, then you have no number in front of the x plus 1, x minus 2. You could write the 1 if it makes you happy. It's not going to change anything. So let's look at the graph. Typing in x plus 1 times x minus 2 into my graph, and pulling up the table, I see that negative 1, 0, 2, 0, and 1 comma negative 2 are all there. See, negative 1, 0, 2, 0, and 1, negative 2. So that's how you know you did it right. Okay? So, hope this video is educational, and as that's what it was intended to be. And stay tuned for more videos. Goodbye.